Good evening. Today we are going to solve one problem on compression member, but this problem we are going to solve by possible ways. So we have actually three possible ways. One possible way we have formula which is given in 7.1.2, in which we have actually two formulas. One related with your phi and all, and second we have reduction factor, and third we have that is using tables. So now we have problem that is determine the compressive strength of ISHB 400 column is pinned at both the ends, and height of the column is 3 meter. So we have column section, sorry, this is column section ISHB. So we have this as ISHB 400. And then we have properties of the section. If we will go to IS 808, then we have ISHB properties. You can see area we have 104.66. Then we have overall depth 400 millimeter, thickness of flange we have 12.7 millimeter, thickness of web we have 10.6 millimeter, RXX we will say RZZ 166.1 millimeter, RYY we have 51.6 millimeter, all are in centimeters, so we have converted in millimeters. L is 3000 millimeter, BF we have 250 millimeters. Now you can see, to classify the section for effective area, we have to use table 2, and these diagrams are given in on page number 19. So we have to use these values, that is D, that is of the web, TW, then we have TF, we have this as TF, and then we have this as B. So we are going to find out small d, that is equal to d minus 2tf. D we have 400 minus 2 into 12.7. We will get it as 374.6 millimeter. Similarly, B we have bf by 2, that is 250 by 2 is equal to 125 millimeters. Now using these two values 374.6 and 125, we are going to classify the section by using table 2. Then you can see over here that is B by TF. So B is 125, TF 12.7. So we have 9.84. So you can see this rolled section we have, and we have 10.5. So it is less than 10.5 because epsilon 1 for FY 250, and therefore we have flange as compact. Now we will go D by TW. So D we have 374.6, TW 10.6. It comes 35.34. We have this wave of an IH or box section, and we have axial compression. So this value that is given as 42 epsilon. And epsilon again 1. So this value is less than 42, and therefore we have section as a semi-compact section. That is, web is semi-compact web. So we have web is semi-compact, and therefore our section becomes semi-compact section. So we can have this section therefore is semi-compact section, and semi-compact section means we have A equal to A, and A we have 104644466. This already we have seen, that is 10466 millimeter square. This is my area of the section. So we have over here centimeter square, so multiply by 100, so it comes 10466. Now we have buckling class of this section. We have to use table 10, and by using table 10 we are going to classify this, that is buckling class. So we have I section, rolled I section. So we have first H by BF. So we have 1.6, which is greater than 1.2, means this criteria is satisfied. And then we have TF is equal to 12.7, less than 40. So this is also satisfied. So we have buckling about ZZ axis, we have A, and about YY axis, we have B. So minimum we have B. So we will go for buckling class B. So about ZZ we have is A, and about YY axis we have B. And our effective length is same across both the axis, and therefore minimum we have to consider for the buckling class, which is B, and then by we have slenderness ratio, which is lambda is equal to L effective upon R minimum, and we have R minimum, so R YY, and then from this we are going to get value of lambda 58.14. Now we are going to use three methods. So first method, we have table. We are going to use table 9b, which will give us design compressive stress. We have table 9a, b, c, d for design compressive stress. Our buckling class is b, and therefore we are going to use table 9b. And in table 9b, we have value KL upon R, and KL upon R we have 58.14, and for this 58.14 we have 181 plus. Now we can have this 50 and 60, and that Fy we have 250, and for this we have these two values, and therefore we have 194 minus 181, and this already we have seen in last problem, and therefore I will not explain this, and we will get a 183.42. And knowing this value, we can find compressive strength PD equal to AE into FCD, and substituting value of AE and FCD, we will get compressive strength as 1919.67 kilonewton. Now method 2, we have slenderness ratio 58.14. We will use now stress reduction factor tables, which is 8B, because buckling class is B. You can see over here. Again, we have for 250, we have these values of the stress reduction factor. And by using this formula, we are going to find stress reduction factor, which comes 0.8086. And then we will go for FCD, which is X Fy upon R, stress reduction factor into Fy upon gamma MO. And that will give me 183.77 MPa. And then we have PD equal to AE into FCD, and that will give us 1923.34 kilonewton. So in first method, we have value 1919, and in second we have this value as 1923. Now we will switch over to the method 3, in which we are going to find the values by using this formula of FCD. And then we have to go for FCD, Fy upon gamma MO. So this formula we are going to use. And so we have to first find out lambda, then we have to find phi, and then we are in position to substitute value in this equation, and then we will have Fy gamma MO gives me FCD value. So now first lambda, we have to use this formula, Fy KL upon R whole square pi square E, and this phi plus phi square minus lambda square to the power 0.5, 1 upon, we will get that as stress reduction factor. So 1 upon this value, so we have that as stress reduction factor. So we will have this value of lambda by substituting KL upon R, we know 3000 upon 51.6, Fy is 250, and then we will get lambda as 0.6543. Now knowing lambda, we will go to the value to calculate value phi, in which we have now lambda value, alpha we know, and alpha value we are going to use from table 7, and for class B, buckling class B, we have 0.34, and then we will substitute these values, and we will get value of phi, that is equal to 0.7913, and then from this we can find stress reduction factor, which we will get it as 0.8088. Or we can go directly for FCD by substituting all the values. We have value of 5.7913 and value of lambda 0.6543. And from this, we are going to get value of FCD as 183.82 MPa, and PD equal to AE upon FCD, we will get 1923.86 kilonewton. So we will get a very small difference between the answers if we will go for any of the methods. So these are the different methods which we can use to solve the problems, but we have to use only one, and is always preferable to go for the tables. So thank you. So we will stop here only.